This is a tutorial video introducing the idea of density and how we can calculate it for regular objects. This comes up in Unit 3 of AQA GCSE Physics and Combined Science. By the end of this video, you should understand what is meant by density and be able to relate differences in density to the particle model. You should be able to recall the equation to calculate density and calculate density for objects when the mass and the volume are given. You should be able to convert masses and volumes that are not given in SI units and calculate volumes for regular objects. Density is a measure of how much mass is contained within a standard volume of a substance. In other words, if you have a series of objects which are the same size as each other, then which one feels the heaviest? Let's say that we have a metre cubed of iron, water and chlorine. The iron is a solid, the water is a liquid, and the chlorine is a gas. They have quite markedly different densities. Even though the boxes are the same size and have the same volume, the iron has a mass that's around 8 times higher than the mass of the water, and the water has a mass that's over 300 times higher than that of the chlorine. This is because of their different densities. We can relate this to the particle model that we met in the previous video. Iron as a solid has far more particles packed together in the same volume than either the water, which is a liquid, or the chlorine, which is a gas. It's the arrangement of the particles that causes this difference in density, not the mass of the particles themselves. A little bit later in GCSE chemistry, you're going to learn that actually the mass of a chlorine molecule is about 4 times higher than the mass of a water molecule. But the difference is that there are far more water molecules packed together in a liquid than there are spaced out in that chlorine gas. Like so many other quantities in GCSE Physics, density has a calculation that you need to memorise. Density is represented by the Greek letter rho, which looks a lot like a P, and it's found by dividing mass by volume. One of the great things about density is that, rather like speed, it doesn't have its own special unit. Instead, the units are made from the units for mass and volume. We tend to measure density in kilograms per metre cubed, and this can help you to remember what the calculation is. If you know that the slash sign is a divide sign, then you can see just by looking at the units that we need to do the mass in kilograms divided by the volume in metres cubed. To begin with, let's look at some examples where we're given the mass and the volume. In this worked example, a block which is 0.75 metres cubed is found to have a mass of 240 kilograms. Now in this instance I've actually told you that 240 is the mass, but even if we hadn't done that, we know that kilograms are the standard international units for mass, and we know that volume can be measured in metres cubed, so we can use those units to identify which quantity goes where. So I'm going to need my density calculation, mass divided by volume, and I can see that I'm going to need to divide 240 by 0.75. That gives me an answer of 320. The reason that the answer has got bigger is because I'm dividing by a decimal. And then of course I need some units. Kilograms per metre cubed. Now here are 5 more questions of the same type for you to have a go at. You may struggle with the last one, but give it a go, and afterwards we'll talk through how to do those conversions if you're a little bit unsure. How did you get on? Hopefully for question 1 you divided 480 by 0.6, getting a density of 800 kilograms per metre cubed. Then for question 2 you divided 1200 kilograms by 0.8, getting a density of 1500 kilograms per metre cubed. Then for question 3 I hope that you spotted that the numbers had been switched over. Remember, those units are always going to tell you which one's the mass and which one's the volume. So 7,200 divided by 0.9 gives an answer of 8,000 kilograms per metre cubed. 6,300 divided by 1.2 is going to give a density of 5,250 kilograms per metre cubed. And then this last question was tricky, because here we've been given the mass and we've been given the volume, but not using the correct units. So before you could complete the calculation, you needed to convert these. 2 grams is 0.002 kilograms. And 0.5 centimetres cubed is 0.0000005 metres cubed. So if you then divide the mass by the volume, you get a density of 4,000 kilograms per metre cubed. Let's talk briefly about non-standard units. In physics, once you know what you're doing, conversions are usually pretty straightforward, because absolutely everything in the metric system is connected by factors of 1,000. There are 1,000 grams in a kilogram, and 1,000 milligrams in a gram, and 1,000 micrograms in a milligram, and 1,000 nanograms in a microgram. But here's the problem. Centimetres don't fit into that nice metric system. They just happen to be the favourite unit of length for regular human beings who aren't super into science. And so if you're going to measure lengths in centimetre, or volumes in centimetres cubed, then you're going to need to remember one set of conversions that don't fit that pattern of thousands. Let's consider a cube. And let's say that this cube has sides that are all 1 metre in length. Now the volume of that cube will be 1 times 1 times 1, 1 metre cubed. Now you also, hopefully, know that there are 100 centimetres in a metre, but the question is, how many centimetres cubed are there in a metre cubed? If we come back to our cube here, we can remeasure the sides, but in centimetres instead of metres. So if every side is 100 centimetres, then the volume will be 100 times 100 times 100. 1 million centimetres cubed. So now you need to remember that there are 1 million centimetres cubed in 1 metre cubed. Hopefully that makes sense, but just to be sure, let's do a couple of quick calculations. So let's say that I've calculated that the volume of an object is 600 centimetres cubed. Well, if I want to work out its density, that's no good to me. I need the volume to be in metres cubed. So to turn centimetres cubed into metres cubed, I need to divide by 1 million. And so my 600 centimetres cubed is going to become 0.0006 metres cubed. Here are 5 more examples for you to have a go at, so pause the video and write down the answers now. Hopefully you managed to work out that 500 centimetres cubed is 0.0005 metres cubed, 2,500 centimetres cubed is 0.0025 metres cubed, 45 centimetres cubed is 0.00045 metres cubed, 7,500 centimetres cubed is 0.0075, and 150,000 centimetres cubed is 0.15 metres cubed. When calculating density, you may also need to convert masses in grams into kilograms, but this is much easier because this is just a standard metric conversion. So to turn grams into kilograms, we divide by 1,000, so 4,500 grams becomes 4.5 kilograms. Pause the video and write down what each of these masses is in kilograms. 25 grams is 0.025 kilograms, 350 grams is 0.35 kilograms, 4,500 grams is 4.5 kilograms, 50,000 grams is 50 kilograms, and 750 grams is 0.75 kilograms. Now that you can do the maths of calculating density, let's talk about how we would actually measure the density of an object. So say that I gave you a block, and this block is 20 centimetres by 10 centimetres by 5 centimetres, and it has a mass of 3 kilograms. How would you measure the density? Well, you'd need to work out what the volume is, and you'd need to use the mass which we've been given. So firstly, you need to think about how does one measure the volume of a rectangle? So the volume of a rectangle is found by multiplying the length by the width by the height. If I multiply all of those together, I get 1,000 centimetres cubed. But as we know, these aren't the appropriate units for measuring density, so we're going to need to convert. 1,000 centimetres cubed divided by 1 million is 0.001 metres cubed. Then I can take my density calculation, mass divided by volume. The mass has been given as 3 kilograms, so I do 3 divided by the 0.001 volume that I've worked out, and I get an answer of 3,000 kilograms per metre cubed. We could go through a very similar process if we wanted to work out the density of this cylinder. Firstly, I'd need to calculate the volume, although I'd need to use a slightly different formula compared to the one that I used for the cuboid. And then I would need to measure the mass using a scale or a balance. And then I would be able to calculate the density of the cylinder. So the volume for a cylinder is found by doing pi r squared to find the area of the cross-section, and then multiplying this by the height of the cylinder. So I've got 9 pi, because 3 squared is 9, multiplied by 20, and that gives me an answer of 565.49 centimetres cubed. I'm not going to round that answer now because I'm not done with my calculation, although I will need to round it at the end. Next, I need to convert that volume into metres cubed. So again, I divide it by 1,000,000 and I get 0.00056549 metres cubed. Now the mass is also going to need converting so that it's in kilograms. And to do that, I divide by 1,000. So 60 grams is 0.06 kilograms. Now I can use my density calculation. Mass divided by volume. 0.06 kilograms divided by 0.00056549 metres cubed gives me an answer of 106.103 kilograms per metre cubed. Now, because the numbers in the question have all been given to two significant figures, I should give my answer to two significant figures as well. So I'm going to give my final answer as 110 kilograms per metre cubed. Here's one final opportunity to practice these calculations for this video. So in my worked example, we're asked to calculate the density of a block that measures 10 centimetres by 20 centimetres by 3 centimetres, and we're told that it has a mass of 120 grams. So firstly, I need to work out the volume, which I do by multiplying all of those dimensions together. Now I need that volume to be in metres cubed, so I divide by 1,000,000 and get 0.0006. The mass also needs to be in kilograms, so 120 divided by 1,000 gives me 0.12 kilograms. Now I can complete my density calculation. Density is mass divided by volume, which is 0.12 divided by 0.0006. That gives me an answer of 200, and my units are kilograms per metre cubed. Pause the video and have a go at the last three questions yourself. Question 1 is in the exact same format as the worked example. So firstly, you multiply together the three dimensions to work out the total volume, and then you convert that to metres cubed by dividing by 1,000,000. That gives you 0.0015. The mass will also need converting. 750 divided by 1,000 is 0.75. 0.75 divided by the volume of 0.0015 gives you a density of 500 kilograms per metre cubed. For question 2, you need to identify that a cube will have sides that are all the same length. So the volume will be 20 times 20 times 20, which is 8,000, and then 8,000 divided by 1,000,000 to put it into metres cubed is 0.008. The mass again needs converting, so 3.2 kilograms divided by 0.008 metres cubed gives a density of 400 kilograms per metre cubed. Then finally, for question 3, you have another cylinder. So firstly, we need to square the radius of 5 to make 25, and then you're going to do 25 pi multiplied by the length of 10, so that's 250 pi, and then divide all of that by 1,000,000 to get a volume. So that's 0.000785. Again, the mass is going to need to be in kilograms, so we convert that to 3.927 and divide that by the volume, which gives you a final answer of 5,000 kilograms per metre cubed. Thank you very much for watching, and I hope you found this a useful introduction to density calculations. The next video will look at the density required practical and how we can calculate the density for irregular shaped objects. If you did find this useful, then don't forget to like and subscribe for more GCSE Physics videos coming soon.